The reason why I did these papers is like when I was like you guys and gals at a conference, there was things I'd always want. You'd want the slides, and you probably want to have some place to take notes, and you'd probably want to have some ideas of like what the speaker thought was at least relatively interesting. So either I failed or I succeeded. At least on the bottom there, you'll see the link to the slides, so you'll be good there. To give you a little bit of background on this talk, so are you all architects, engineers? Anybody anything different? Yeah. So what I do is I do this coaching stuff. I go around and I work with companies and we build stuff. So unlike some of my agile counterparts, I build stuff with more than just Legos, right? I do a lot of code, and I was working with a group, and a different person had come in talking about agile and building products. And this dude came in, and he said, if you're an agile team, you don't plan anything, you don't design anything, everything just emerges, which is a horrible idea. It's wildly irresponsible. And so this got a lot of people super freaked out because they said, classical architects were like, well, then what do we do? And I was like, well, first of all, you ignore what that guy said because it doesn't make any sense. And so that's where this talk kind of came up, because I started seeing this pattern come up a lot where people were saying, well, we're going to be an agile team, and so that means we don't think anymore, we just kind of react, which is never a good idea. So the point of this talk is just to understand when certain decisions can emerge and what decisions you need to kind of get right earlier on and how to balance the two. And that's the intent of this talk. And so when I go through these are the things that I do with teams that I'm coaching and I'm working with to help them understand and kind of find that right balance. So I'll give you lots of examples, things you can do. If I get into any weird agile terms, feel free to throw stuff at me, especially if they don't make sense. If it helps you at all, my background, not that I'm interesting. So I'm from Chicago. If I talk too fast, my apologies. When I talk slow, I sound super sarcastic. So just be aware that if I'm in the middle, I'm not being rude, I'm just trying to slow down. I was an architect at the Mercantile Exchange in Chicago for far too long. Has anybody heard of the Mercantile Exchange, Futures and Options Board? You have any friends or family there? Good. It's a horrible place. It's a horrible, horrible place, and I was there far too long. But I did a lot of low latency, high throughput messaging, all that fun stuff. When I left CME, I was at Red Hat for a few years as an architect, and now I just do this stuff. So I've built stuff, I've helped people build stuff. That's kind of where I'm at. All right, I can use this fancy clicker. So my perspective, we build things. And so, yeah, we need to know the context of how the things were being built, but we also have to make sure we build them in a responsible way. I used to always make this comment when I was at Red Hat. I'd go around to organizations and help them with architecture. And so, has anybody in here ever seen the perfect architecture? Has anybody ever walked into a place and be like, man, this place nailed it. It's not going to get any better than this. Yeah, it's never happened. It's never happened. If you're like me, you probably look at this stuff you wrote last year and you're like, man, I was an idiot last year even, so I don't even know how I could get it right. And so this whole idea of trying to get the perfect architecture, you might as well throw that out the window. On the flip side, I've seen plenty of groups get stuck in this space where they're trying to get it perfect, and so they never finish anything. And I see that more often than I've ever seen the perfect architecture, or even a nice architecture. So we have to embrace this fact that we're going to be wrong, these things are going to change, and we just need to be able to create systems that are maneuverable enough to adapt to change. When you left, my intent with this talk for you is like Monday when you're back in the office and you said Surge was great, these are some things that I think you could be trying out or doing. Obviously, I want you to be aware of this idea of less about what architecture and more about when are these decisions important. That's kind of fundamental for the talk. If I fail there, then feel free to say, horrible job, Joel. I want to give you ideas on how to use product context to ground decisions. And just like, so here's another thing about me. I am horrible with names. I say dude a lot, and I'm going to try not to swear. If I get that well, I'm doing pretty good. So there was a dude yesterday that talked from NASA, which I'm sure I've probably never said that in my life, the dude from NASA. But there was a dude yesterday from NASA who was talking about You need to understand the experience, but you also need to get things right. And so when I talk about product context, I'm not just talking about make sure it looks nice and make sure people are happy. There's also the whole real world scenario of like when 10,000 people are trying to hit your system at the same time, what is the experience like then, and how do systems degrade gracefully, and what happens when bad things happen? Because that's part of the experience too, and that's the reality of the world. So I want to have us talk about ways to use product context to ground our architectural decisions. Then, of course, the last 2 points on there, this idea around what you actually should document and what people need to be aware of. Again, kind of in this agile space, people say you don't document anything because that's not agile, and that's just pretty much nonsense, right? There's things that people need to be able to be aware of. There is this, man, I can't remember this dude's name. So one of these philosophers, pseudo-philosophers, pseudo-computer scientists said, like, you'll never know what was in the minds of the engineers when they built the thing. Right? Even the best documentation won't express the ideas and the developer's understanding of the problem space. And so you don't want to document why you made a certain method, but you want to start thinking about the decisions you made and try and give information around the points of the decisions. And then lastly, there are some practices to keep your architecture loose and timely. All right. So what's the problem? That's super weird because problem is red in the slides. Does it look red to anybody? No. Okay, so that's a different problem. So to first understand this idea of what architecture problem, we should probably investigate what the problem space is. Is this architecture to everybody? I mean, it's small. It's not a big system. But is this kind of like architecture? No? What's different for you, dude? I'm sorry? There's nothing connecting the pieces. Awesome. So you're going to see that in a second here. Yeah, so good call out. There's nothing connecting the pieces. When I think about architecture, I think about it as just a way of modeling our understanding of the current problem space. We need to talk about interactions and collaborators and how systems depend upon each other. Architecture was never meant to be about frameworks, right? So don't fall into that trap. Presumably you're all smart enough for that space. Has anybody heard of this idea of technical debt? Yep. So let's see. Let's get one definition of technical debt and let's see who agrees with it. Who wants to be brave? How about somebody on this side? Technical debt. Anybody? Or the dude in the middle? Dealing with the bad decisions of the people before you, because we've never made them, right? Who agrees with that statement? It's dealing with the bad decisions from everybody else but me. Yeah? Yeah, all right, cool. You have a different one, dude? Well, yeah, shortcuts you made before.
That isn't always like a bad thing.
Yeah.
Like I could build the perfect infrastructure. It might take me a year.
Yeah.
And cost all the money the business has.
And then we don't have a job.
We don't have a job. So it's like, hey, as a technical guy, let's all stay employed.
Yeah. Let's stay employed long enough till we get a better gig. How about one more? The stuff you can change if you had time. Stuff you want to change if you had time. Yeah. I think. I read this description from, so all good descriptions, so kudos, you all get gold stars for that. I read this description from Ward Cunningham a few months back, maybe a year ago, that I really liked. So Ward's the dude that came up with the wiki, kind of created this idea of technical debt. Ward had it was a very much more empathetic approach on technical debt. He said technical debt it wasn't that we were making bad decisions, it was we made the best decisions given what we understood at the time. And what happens is your understanding of the problem space evolves over time. And so your technical debt then is the delta between your understanding now and your understanding then. I thought that was a really nice statement. It wasn't like those other people before us just were trying to screw us over. It was they didn't understand the problem space well enough. And so I apply that same space into architecture. If you think about architecture, at the best case scenario, it's a model of our current understanding. But if architecture is static, then we lose because our understanding of the problem space evolves. So if you have this as a simple architecture, you could probably maneuver through these things, and there's lots of things even missing from here, right? If you have caches, there's not even listed here. If you have different access points, various mediums coming through, not even referenced here. So a simple app would be much more complicated than this. So I've been using these models similar to this. This is a book from Notes on the Synthesis of Form from Christopher Alexander. Anybody read this fabulous book? Yeah? What'd you think? Yeah. So don't go to the last chapter. All right, I think it's like a 9-chapter book. But this book is beautiful because it's an old architectural book, but it talks about the challenges we face. And so in this model up here, what he's saying is like every decision point. Now this book is about actual building architecture. So he talks about building, mud huts versus buildings and all the trade-offs you have to make. But the concepts apply directly to the things we build because just like the gentleman up here was saying, all the things we build and all the decision points we make in our products, they're not just boxes in a UML diagram. They have connectivity and they have tissues to each other. And increasing one can have an effect on other. When he was talking, and Christopher Alexander was talking about this, he was talking about simple things like if you have a model where you only have 4 points of decisions, you can probably manage that in your head, and you can probably find the best fit for this solution. In this example here, if you increase performance, then the cost or the effective jointing decreases and so on and so forth. But the reality of our world is we have much more complicated decisions to make. If all of our apps were simple, then the architecture would be trivial. So what happens is, in our real world, our architectures tend to look more like the first model. There's lots of decision points. And they have lots of effects on lots of other decision points. And these are just the decision points that we actually acknowledge. Because again, this is just our understanding of the problem space right now. What we try and do as architects and as builders of systems is we try to find the optimal grouping of these components and decision points to actually be able to make an intelligent decision. If we try to maneuver 15 points of inflection, we lose. There's just too many permutations, too many things can go wrong, so we try and create these logical groupings of things. Whether it be using standard patterns or frameworks, we try and do simple things to be able to reason through these systems. On the bottom is what tends to happen. We tend to get stuck in this space of, here's the known decision points, and then the language of the problem space biases us. And so instead of finding an optimal grouping, we find the grouping that we can actually wrap our heads around now, and it's usually affected by language. And I don't mean language like Java. If you're writing C++, I do mean language. Just a joke. All right? I don't mean language like that. I mean it's the language of the technology space. So we get stuck up in thinking, well, if we build some things with microservices, it'll solve these problems, and if we do things with containers, it'll solve it this way. And so, like, instead of actually embracing the problem space, we start applying our understanding of technology and terms and create a less than perfect model. And so we have a biased simplification of what could happen. So if you apply this same concepts to software, we're at Surge, so I'm guessing everybody here doesn't have simple architectures. Does anybody have a simple architecture where it's just like, man, I have 10 people using WordPress? No? Anybody beyond 10 people at WordPress? Don't get me wrong, if you've used WordPress, you know it's not fun or easy. Most of the stuff we have is non-simple, and there's multiple decision points, and all the components have these interdependencies. And as things change, the dependencies change, and they have trade-offs as we go. And we get biased by the solutions language that we use. We get biased by time constraints. And so all of this just to say, like, the problem is we can't just take what we know now and apply a model and assume we're going to be right. But on the flip side, we can't just say, it's too hard, let's just figure it out as we go. So here's what we can do, and here's the stuff that I do. So again, I say, I'm using product to ground decisions, but when I say product, don't take it just as, somebody has to have this thing look nice. It's always way more complicated than that. So here's an example of a group I was working with. If you show up in here, or your friends show up in here, my apologies. I tend to take pictures and show a lot of examples, so you can see this isn't just me hypothesizing. This is a group that was doing some tax software. So, not the most, let's be honest, tax laws are pretty ridiculous, right? We're in DC, we can say they're pretty ridiculous, lots of unnecessary complexity. And also a large user base. And so they were rewriting some of their tax software for various counties throughout a small section of states. And so what's happening inside here, let me point for a little bit. I'll come back in a second, I promise. So what we do with these groups, we get them understanding who's going to be using the product and how they're going to be using it, right? Just kind of simple simple grounding of the product ideas, personas, design targets, all that fun stuff. This happy dude is the enterprise architect, right? Because they always love being in these discussions. But what we were doing was we were exploring building this product, and then whenever he had a concern, he would phrase it as a question, and we would see what it would affect. So all of these orange stickies were his questions. Things like, what about data integrity? What about performance? What about failover? How should these things function? How should these things happen? What are the downtimes? What are the off times? What's the scale going to look like? How's it going to burst? And we were saying, when are these questions relevant? And what questions don't we know? And what questions are irrelevant? And so we started creating this flow, and this is not even based upon any type of release. It's just, at this point in time, it was just an exploration tool to say, based upon his real architectural concerns, which concerns were definitely valid, which concerns weren't valid, and the ones that were valid, when would they start to become an issue? And of those, are there certain things that have to be right? You can see those two orange stickies under where it says Jenny Westlow online. There was two constraints that he had, two concerns that he had, that if we didn't get those right, nothing else mattered. But he had a whole realm of things he was concerned about. So we use this as a way to figure out when were your considerations, when were your challenges relevant, and who were they relevant for. This is at the onset of a project. Give you a different example in here. So this first example is a first team kind of planning out a big release. This is where we're going. Here's all these considerations, these concerns. Here's where things fall into place. This next slide is the next level of fidelity for a different group. This group, ironically enough, this was an infrastructure group I was working with, and they were building Network 4.0, which is a horrible, horrible name. And even I asked them, I go, what happened to 1, 2, and 3? And they said, well, 1 was the first one, 2 was the better one. We skipped 3 because it was just horrible. And so now we're trying to get 4 right. And I was like, oh, this is going to be great. But we started with similar things in here, and so I'm working with 30 infrastructure architects. This is a large organization, and ironically enough, what they were doing the next week is they were bringing in vendors, which is, who in here is a vendor? I don't want to offend too many people. All right. So I used to be with Red Hat, and so I can tell you when people would bring in Red Hat, I wouldn't tell you what you needed to know. I would tell you what I wanted you to hear. And so that's what was about to happen. They were about to bring in a big network switch company, blah, 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 to come talk about Network 4.0. And the company was bringing in their architects to tell them how this company should build their next network. And so we sat down before the vendor came in and said, we did all this stuff, kind of like, what's this about? Where are things going? And we said, when these vendors come in, what are 3 scenarios that are critical to get right? And so we laid these things out in a flow based upon how it would be consumed and how it would burst, and we laid out a flow of how these things would tie together with our systems. And then we could, for each of these passes, we just gave them a simple name. The first line is about adding capacity. When we need to add capacity to our network infrastructure, how should that happen? Who needs to be notified? How does it work? When we need to do maintenance in our infrastructure, what should happen? And so now what happens is when the vendor came in the following week, they didn't get to just show up and do presentations. They had to walk us through this with our context and say, how do you help us do this? Because if you don't, we don't really need you. The vendor didn't like that, and they didn't show up. Or I'm sorry, they showed up, and they ended up leaving and having to come back the following week because they weren't prepared. But it's not that the vendor was bad. It's just that now the company had control because they had a better idea of the decisions they needed to make now, as opposed to like getting the list of things they could possibly do in the future. And so this is pretty powerful for them. The other thing we did with this group who here's seen The Price is Right? Like the old Price is Right. I haven't seen it myself. I haven't seen the new one. But like in the old Price is Right, they used to have that that little dude that went up a mountain and he was like yodeled. You ever remember that? And then we got to the top, and he fell off the mountain. Yeah. So what I did with the group, again, remember this is a bunch of infrastructure architects, and so they started saying all of these things about Network 4.0. It had to be reliable. It had to be speedy. It had to be easy to use. And so they would use all these terms without actually explaining it to it, which is what good architects do. And so what I did is I said, let's take a pause here, and I drew on a whiteboard, and I said, let's take speed as an example. On one side of the spectrum on speed, we have real time. It's gonna, as soon as you need something, it's gonna be there for you in milliseconds. On the other end of the spectrum, there's like where you're at today. If somebody needs something, it takes a day or two. So where on this spectrum when you say speed, where does this group mean speed? And so everybody kind of like I started with a little marker and I started drawing from like, real time to the 5 minutes. And I said, when you feel like this is your point to scream, scream. And so then like, you'd hear like, ah! And so like you started getting an idea now what speed really means to everybody. And we did the same thing for reliability. We did the same thing for fault tolerance, just to get this common context about when I say speed, what I really mean is we should have something in a few minutes in these scenarios. For these other scenarios, it's going to be harder and more complex. But at least this way, we're getting more consistency in our approach. So again, we are using this idea of this network as a product to figure out what are these decision points we need to make now, what's important to us, and then when the vendor came in, help us understand how they could actually help us. All of the decisions you're going to make, we need to make intentional decisions. Just not at the same time, and not all decisions have the same risk. When I first started talking about decision points in architecture, I used to just use the same kind of spectrum. I like to use spectrums for some reason. And I would say, these decision points go from like really cheap to really expensive, right? So like really cheap might be like if we change the logging framework, it should be a cheap and trivial change. If we try getting away from Oracle, they're going to sue us, and it's going to be very expensive. And so what we needed to do as architects is figure out there's this span of like very expensive versus very cheap, and our job to be responsible architects was to push as many decision points from super expensive to cheaper. And so I started doing these kind of models, and then I started saying there's these things that are isolated versus dependent, and you can drive good architecture from dependent to isolated, but it's really hard to go from unknown to known. So some of these things you actually have to build things to understand the problem space better. So I started using this as a way of modeling to figure out which decisions did we have to do now versus which could we defer. So to give an example of this, back when I was at the Mercantile Exchange in Chicago, we had to do a lot of stuff with market data, right? So Mercantile Exchange, takeaways are a horrible place. Also, what you have to do is you get a lot of messages super fast, and you have to figure out if there's a buy-sell match, right? So when you're building these things, there were certain things you had to get right. If the matching algorithm was wrong, you couldn't evolve into it, right? If somebody makes a trade for $1 million, you can't say, oh, sorry, the algorithm wasn't quite right. We're getting there. Try again next week. They don't like that idea. Message latency was something that we needed to get right early on. It was a high dependency space, but it was a little more uncertain. Because with us, with message latency, we started off with a distributed system. So we did a lot of data segregation to isolate out the problems. But what happens is, once you go to distributed systems, like you all know, if you go fast enough, eventually the network becomes the problem. And so you go from a distributed system, then you start pulling things back together because the network's the problem. And so we had to, this is a little bit more, we knew how to handle message latency, but we didn't know what would happen over time. So it was a little bit more uncertain, so we had to start playing with these things. Logging framework, it was cheap, isolated, right? We could swap those things in and out. The APIs, if we were going to do containers or not, those things were relatively isolated, or we can play around. But we knew right off the bat there were certain things that couldn't just emerge as we were building platforms. We had to get certain things right. And there were certain things that if we tried to get right now, it would just get in the way. So we use this as a way of modeling this out. This last example is with a group I was just with. If you remember a few slides back, we're doing these maps to talk about where decisions are at, using those slices or journeys, those vertical blue lines, to figure out what we're going to solve first and give it a context. In this picture, what we're doing, we have all the other artifacts, but this architect here is talking with a team, and he is using these dots to talk about how things are interacting together. So in this space, in this thing we're building inside this actual part of the UI, this is going to be a service call. And we're trying to do domain modeling to figure out, anybody here building microservices? Yeah? It's really easy to build them wrong. So it's really hard to get the domain right. And so in this space, before we were getting into the services, we were looking at the thing we're going to build and trying to figure out where does the domain models actually exist across these things to build services that were actually going to be used and designed in properly isolated ways. So he's walking through with the teams, talking through about the service calls, trying to create this domain model based upon the product that they're building. So we have these maps, we have these connected journeys, and then in here we're just annotating parts of the features so we can see how all of these things are coming together. You layer that with some of those, that previous slide with the quadrants to talk about the cost of these changes, what if we're wrong about these things, and you start to get to nice decisions. These are the things we have to figure out sooner than later. If I go back to this network slide, there, too far. If I'm working with another team that's actually just building a different product, and so imagine if you could, like the top one, if the top thing was the first thing you wanted to build, call it your MVP or call it release 1 or call it something. If this one in the middle is your next release or even your next sprint, and this one down here is the one after that, if you find an architectural decision point that's further down in these examples, then you have this simple conversation. Do we need to get that right now? Or do we just need to get it right before that sprint or before that release? And that's just a nice way of balancing out these things visually and gives teams concepts of we're not ignoring everything, we're just going to make sure we don't try and consume it all at once. All right. The assumptions of your architecture. I know nobody makes assumptions when they're building things, so humor me as if it happened. Everybody know what this one is? Come on, it's the bright shiny ball. You guys, we all love it. We all run towards the bright shiny objects, right? When you're building these products, be thinking about how it will be used versus what you want to build, right? I did this presentation at a insurance company up in Milwaukee about, probably about a year ago. And so I was up there talking about product engineering, product coaching, those types of things. And I made this slide about resume-driven development, right? Kind of overlaying that, talking about Docker and microservices and all this other fun stuff. And then the dude after me got on stage, and he said, so what I was saying, don't fall into the trap of having to do Docker and microservices just because it's the cool thing. Don't get me wrong, they're cool stuff. Don't fall into the trap, kind of understand your problem space. The dude after me got on stage, and he was like, everything has to be Docker and microservices and non-relational databases. And I was like, oh boy. We probably should talk before we did this. So be thinking about how your products can be used versus how you want it to be used. Versus what you want to build. But most importantly, versus even if you're ready. And I think that's the interesting spot, right? A lot of places I go aren't ready for some of the cool things that they want to do. If you want to build microservices, which is the cool thing with all the kids these days, if you want to build microservices, but you don't test, that's probably not a good way of doing things. I've been to places, I kid you not, that want to do microservices that have not versioned anything ever. And it's like, you might want to look into versioning before you get into microservices. It's called a hunch. I think this is a bad idea if you don't. So here's the gist of this. Good engineering practices will always lead to better architectures. Bad engineering practices will bring good architectures to their knees. So if you're not ready for something, don't make the move just because it's the cool thing to do. I had a team that was doing microservices stuff. I'll come back to the cat in the hat here in a second for you. Again, I'm sure this is not any of you. So imagine a world where a team is building something, and then two architects come over and they say, everything in the future has to be cloud ready. And here's a slide of what it means. You have to use reactive Java and Hystrix and all this fun stuff, and it has to be deployed using Docker and blah, blah, blah. And then they walk away, right? Because that's what those architects would do, never you. And then I get to sit with the team, and they go, what just happened? And I go, I don't know either. So with that team, these architects came by and said, you got to build things this way. And so they were building a greenfield app that was going to save their company billions of dollars. Billions with a B, right? And they built it, and it was done in about 6 weeks, but it wasn't with microservices. And so these architects came back and they said, we can't release that. It's not cloud ready. I go, this is going to get ugly. And so they made the team spend the next 6 weeks tearing it apart and making microservices. Now, what this thing did, just to give you kind of context, this company sells, I'll use the example of clothes. It's a big retail shop. They sell things for clothes, right? And so if they want to sell a T-shirt, what they do is they price out the materials for the T-shirt. So somebody can bid on buttons, somebody can bid on thread, somebody can bid on cotton. So all these vendors bid on these things. And so the whole idea was you get the cheapest price and then you build the thing and you sell it. That's how they were going to save billions of dollars because they couldn't track this before. They always just got kind of taken to the cleaners on these things. So if you heard that problem statement, you have something you want to sell, and people need to be able to bid on the components of the thing. How many services do you think that might be? And they should probably get notified if they get the deal. What do you think? How many services might that be? Just a wild guess. You can be wrong. But 2, 3, maybe a couple more. Maybe there's some authentication stuff over there. Not too many. Yeah? Yeah, it can't be that bad. Yeah, 35 microservices later, the team couldn't figure out how to put the thing back together. But man, it was cloud ready. They could, every service could go in its own container and scale. Just could not build it for the life of them. And so this is a space where somebody got fixated on this bright shiny ball, and they didn't balance out these decisions. And it was bad engineering practices, right? And everything started to fall apart for them. All right, back to those assumptions. This is a fun one. Similar to the dude yesterday was talking about, if you have ideas, you should be able to just lambast them and all that fun stuff. This is a fun one. If you're making assumptions or making architectural decisions, you should have this conversation. What if you're wrong? What if you're wrong? What would change inside the code? What would change inside the infrastructure? What would change inside the architecture? How could you protect yourself from these things, and what would you change? If you're not even thinking about these things, then you're probably still falling into that bias space and having an unnecessarily biased decomposition. So when I'm having teams think about the thing that they're building and they're making these architectural decisions, a simple conversation with that group that was doing the microservices. You have this product that already kind of works. If these microservices go wrong, what's going to happen, right? And they would say, well, we went with microservices because we thought there was this decomposition where this thing would scale at a different rate than this thing would scale. But if they don't scale at different rates, then I guess it's just going to be harder to build and it's going to be harder to put together, and maybe it wasn't a good idea. But they didn't have that conversation. They were just thinking it's going to work. It's going to be wonderful. So when you're thinking about your products and your architectural decisions, think about what's going to happen when you're wrong. And then when you're building these things, look, products have product assumptions. I assume if you build this thing, then everybody will come and we'll all be millionaires and everybody's happy. So you should document your product assumptions that you're making, but you should also be documenting the technical assumptions you're making. because the technical assumptions you have today aren't going to be relevant maybe even next year. When I was back at the Merck, we had relational databases everywhere, and so we started to think in a relational way. But the assumption was that the relational database would always scale properly and would work in our model. But a couple of years later, non-relational databases came up and they scaled better. And so our assumptions were invalid now. So think about the assumptions you're making at a product level, the assumptions you're making at a technical and architectural level. Revisit those. Think of ways you might be wrong, document those. And then for each of those errors, think about what would change. Because some of those things that might change, you might say, this aspect might change. We think we're going to go deploy on one cloud and then we're going to do a different cloud or something like that. If we had to do that, is there a better abstraction we should take? If there's a better way of separating out components, maybe we should think about those. No. Now, if you can find ways that you might be wrong and protect yourself from it now through a better abstraction or through a better engineering practice, you're going to be in a much better space when those changes inevitably come. And last but not least in this space, ground your decisions. And I think this is hard for a lot of teams. The root of a lot of architectural decisions it was based upon an underlying principle you're trying to drive to. So I use this with teams that are getting hung up on DevOps. Again, everybody here is super awesome, so nobody here get hung up on DevOps. But I go places and they say, we want to buy the DevOps. And I go, okay, I don't even know what that means. But they'll say things like, well, we already bought Atlassian Suite, so we have Jira, so we're Agile. And we already bought Chef, and we're working with CloudBees, so we'll be DevOpsy. So we just need to, finish the spectrum. But the reality of the world is, they bought all the tools, but, they haven't really thought about the values behind them. What are the things you're driving towards? You're driving towards repeatability in determinism environments. You're driving towards collaborating with teams, those kinds of things. And so for your architectural decisions, if you're stuck in this space of here's just a tool or a framework or a solution space, and you're not thinking about what it's actually about, you're probably missing the boat. So it's to sit down with your teams and have these conversations. If you're saying look, we're going to go with all containers and we're going to use Spinnaker for everything else, and that's just the way it's going to be. Yeah, cool. But why are we doing this? What's the root behind it? And do we really even have that problem? Man, I had a group in Chicago that was worried about scaling a Ruby app. They were like, oh, yeah, we got to get in the cloud. We got to get in the cloud. It's got to scale. I go, that's cool. How many users do you have today? We have 4. Okay. How many do you think you'll have next month? I don't know, maybe 6. It's I don't think that's your problem right now. That's not to say you don't need to be thinking about these things, but it was the wrong time for the problem. And so just look at these decisions you're making. Is there a root problem underlying it? And make sure everybody understands that, because look, the tools and the frameworks, these things are all super volatile. If you get the values right and you get the practices right, you'll be in a good space when the tools change, because it's going to happen. Look at your constraints. There's never been a perfect architecture. So this is kind of that staying loose and timely. How do you keep your architectures loose and timely? Just look, accept it. It's not going to be right. Of course, if your manager asks or anybody else is oh, well, this is the good one. But it's never going to be right. Just take that statement I mentioned from Ward about, it's the best understanding we have of the problem space today, but it's going to evolve. We understand the things we have to get right. There's a bunch of other things we don't know. We got to figure them out. We got to learn about these things. So use these product discussions to see what decisions you need to make and when you need to make them. And lastly, grow the context around your decision points. Document your assumptions. Talk about why you made these. When are these decisions could be invalidated? But also, also revisit these decision points. But also, think about these for your constraints. What could you do about it? So, back when I was at the Merck used TIBCO for everything, because TIBCO was At least as we were told, it was the fastest messaging platform you could use at the time, so that was the decision point we had. But we didn't do any interfaces to TIBCO. So TIBCO loved that because we could never get off TIBCO. But even if you have these things and you have these constraints, we have to have fast messaging. Okay, so we have to use this solution. Okay, but is there a way we can do something about that constraint? Yeah, we can put an interface in front of it. We can do something. We can put an abstraction in front of it to protect ourselves from these things. Be thinking about those kinds of things. Be thinking about your constraints. Are they necessary or accidental? Man, a lot of the constraints we deal with are accidental because nobody asks, why is this real? Don't get me wrong, there's some super necessary ones, like the dude mentioned about like, we should probably keep our job. That's a good necessary constraint, right? Get something out the door. But understand for these constraints, are they actually real or are they just accidental? And similarly, that's the space. Are they assumed constraints or are they real? By assumed constraints, here's the most, this isn't an architectural thing, but this is an assumed constraint that I've dealt with in a lot of teams. In a lot of places I go, more than one team builds the product, right? And so the assumed constraint is I can never touch their code base. Maybe you're all in better spaces than I am where people like each other, but a lot of places I go, they don't like each other so much, especially outside their teams. And so the assumed constraint is I can never touch their code. It wasn't a real constraint, and so we started doing nice things where we would just, look, you're building services and everybody has to be dependent upon each other, and so you have contracts between each other. It's much better to express those contracts as low-level tests, usually at a unit level, than wait for integration to figure out if those contracts are actually being violated. So we had teams that were just writing unit tests for other teams to find out sooner if they were violating their contracts. The assumed constraint was I can never touch their code base, but the reality of it was we could, as long as we did it in a way where it wouldn't, they would get notified, but it wouldn't break their stuff right now. And so we just kind of explore these constraints and figure out if they're assumed or real. On the flip side of that, would new constraints actually help your decisions? If you're not doing this thing, man, by all means, this is a cool thing to do. And what I mean by this, if you're building a product, you're trying to build infrastructure out there, maybe what you want to do, because it's too hard to reason across all of the pivot points, maybe what you want to do is you want to actually apply your own constraint to the problem space to simplify the model. So instead of it being about all of the databases, you choose a database. So for example, I was working with this group trying to automate everything because that's what you do. And so they had of course, Oracle RAC, Postgres, MySQL, and some non-relational databases. And so this group says, well, we have to automate everything and make it available as a service, blah, blah, blah. They didn't know how to do it or where to start, but they wanted to, model out everything to solve all of the databases. And so the real easy question was, well, why if we just chose one? Maybe it's not all of the databases, maybe it's not all of the environments, maybe it's not all of the products, it's just a little slice of these things. Would applying our own intentional constraint make it easier to kind of reason over this thing? Similarly with like this idea of not applying new code. What if we took what we had and we said, say, no new code, we want to we want to rebuild it in a different way? Is that a constraint that would help us make a decision? Or other kind of ilities, right? Must respond in less than 2 seconds. Maybe you could apply other new constraints. It has to be within a certain skill space. It has to take less than X approvals. It has to have certain level, a low level of complexity. Think about those things. If you could apply new constraints, would that help you reason over your decision points? Lastly, so this is our job, at least to me, maybe not to you. Our job as architects, you take a world of possibilities. I mean, that's the fun stuff, right? As engineers, the world's your oyster. You can have all these things you could possibly do. Apply proper understanding, apply proper constraints to make intentional decisions to deliver maneuverable systems. And so what I mean by maneuverable systems, I mean systems that you get the right things right, but as you learn more, you can maneuver around new decision points. and you can build products that bring joy, not just to your customers. Oop, I must have lost something there. That brings joy not just to your customers, but also to future engineers. Because man, if you're an architect, the best thing you could do, and it wasn't me, because I was not that dude evidently, but no, I did kind of have happened once. But anyway, this one dude came up to me, and somebody had come talk to him 6 years after he had left the company, because this architect had written this kind of torch the ground report on EJBs about all of the problems that were going to happen if they went EJBs, which, if anybody here has used EJBs, that's probably what happened. But somebody came up to this dude 6 years after he had left and said, man, when you wrote that paper, the architecture changed and they didn't go with EJBs, they went with simple POJOs, and he goes, it's been nice ever since then. And I think, man, if you're an architect and somebody comes up to you years later and says, man, that one decision you made has made I can tell it's made my job easier or made my life easier, man, that's a nice feeling. I got lucky in one space where I helped somebody with a cache, but it wasn't nearly as cool as that. It was like a month later, somebody's like, that cache thing was a good idea. I was like, oh, it was a cache. All right. So recap, just be aware of the models that you're building. Are you being biased by the technology decisions? Are you being biased by the language? Use these things, look at your dependencies, how the things interact with each other. Use your product discussions to figure out what decisions do we have to get right, what decisions can we defer, and then how do these decisions affect each other? And then bottom of there, use those things to understand which parts need to emerge and which parts you need to kind of have right. A couple books to check out if you haven't read them or checked them out. I highly recommend Jerry Weinberg. Anybody here read Weinberg? Yeah, good guy? What do you think? Jerry Weinberg. So there you go. If you get the dude doing the horns and he says, I love Jerry Weinberg, that's probably a pretty solid background for you. This book just is really kind of about wrapping your head around problems. This is the idea. If you can't think of ways that something could go wrong, you probably don't understand the problem well enough, those kinds of situations. Weinberg has phenomenal books on systems thinking, complexity thinking, technical leadership, whatever you want, good solid stuff. Check out his stuff. And then in the bottom there, Christopher Alexander's Notes on the Synthesis of Form. The Notes on the Synthesis of Form, it's a pretty short read. It's about 180 pages maybe, somewhere in there. It's not super long. You can check it out. Pretty easy to grasp and have a good impact on you. Just a heads up, if you read this book from Weinberg, super easy. If you read some of Weinberg's other books, especially a systems thinking book, so I love his systems thinking book. But it's one of those books, like, it gets into math pretty deep, pretty fast. When I read his systems thinking book, maybe I'm just slow, but it didn't hit me for about 3 months. And I was like, oh my God, no, I get it now. It was pretty revelationary for me. But some of his books are a little heavy, just so you know. So there you go. Recommended reading. That's me. I do that stuff. I'm teaching a microservices stuff, but nah. What can I answer for you all? What can I do for you all? Yeah, what's up, dude?
So you were going on about, obviously, dues, which is important.
About what?
Dues, which is important.
Yep.
But also, you talked about making decisions ahead of time to insulate yourself from problems. That feels like sort of like premature.
Prematurization, yeah.
So how do you balance that out? Because I've seen a lot of times man, I don't know exactly what we're gonna do, so I'm gonna stick some middleware in here.
Yeah.
And then you're like, oh man, I have all these problems because I
Stuck middleware in there. Yeah.
We hit that a lot.
Yeah. Whenever I find those decisions where it's like I need to get something right earlier on, so if it's like the middleware thing or it's something else, when I have that, so I always start off with this thing about the product and where these things are going, and then kind of overlay on top of those things decision points. So when I'm overlaying on these things, these decision points, if somebody brings up something, if we're talking about middleware or caches or authentication schemes or any of these ideas architecturally, containers, those kinds of situations, I want to frame it in the sense of what do we expect to gain from this? And is there a way we could prove that out faster? And so give me an example or give me a test. If we wanted to do middleware, what's the expectation of the middleware? And give me a concrete example of it helping us. And so let's try and build that example right now. It's not just kind of overlaid in there. It's, if we're building a cache, we assume that if we scale up to 20,000 concurrent writes, we can still do reads at X pace. Let's figure that out right now if we can do it or if we need to figure a different space. It's not just drop it in there and then let's build around it. I want to say, based upon how it's going to be used, what's our expectation and can we prototype that aspect of it?
So just to kind of follow up on that, like I guess I see this a lot within the architecture of an application.
Yep.
Inside of itself, people will be like, well, I don't know what SQL backend we're going to do, so like screw it, let's use Active Record. And I'll just like let that do some magic for me. And I get to go faster because I'm going to cherish velocity in this.
Yeah.
I think we fall into that pitch trap a lot where it's like, I got to go faster. It's like, congratulations, you're now going off the cliff.
Yeah.
Right?
Faster into the wall. Yeah.
So I guess I'm wondering, how do we figure out those decisions? Like, how do we overlay that and say, we all use MySQL. Why can't you just write some SQL here, Rob?
Did you say Rob?
Rob.
Oh, okay. To me. Yeah, no, it's fine. I appreciate it. I appreciate it, man. Yeah. Yeah, those are hard things, dude. I mean, it's kind of like, it's still the same space to me. It's kind of like, if we go this other route, why is it going to be better? And what might go wrong? And again, if we can't think about that thing, if you want to deviate just to deviate, it seems irresponsible. I don't know. I had a dude when I was back at the Merck, this is probably far too long ago, maybe like 10 years ago now. He wanted to build his new app using Grails, right? So, similar, but kind of, same vein. And I asked him that same question. I go, okay, why do you want to use Grails? And he goes, oh, it makes the building, the stubbing of it real fast. I can scaffold it super fast. It'll make this app really fast to get out. I go, what happens when it goes wrong? He goes, well, I don't know. I go, what could go wrong, and how would you troubleshoot it? He goes, well, I don't know. It's like, so just asking those simple questions. It's like, yep, you want to go faster. What happens when? Help me understand these things. And if people can't do it, man, it's not about being a jerk. It's just like, maybe not yet. Yeah, well, yeah, you got that route for you too. What else you got? All right, cool. Well, here's the scoop before you clap. I appreciate it. But just 1 second before you clap. I got a jet for the airport. So I'll be here for like 10-ish minutes if you want to jam. Otherwise, hit me up. We can chat about all these cool things, whatever you want to jam about. It'd be awesome. Thank you.